Hi, it's us again.
We're back.
Hey.
Hey everyone.
Yeah, doing sequences today.
Yep. And moving on to quadratic for higher.
Sequences. So a bit of both today in one video.
Yeah,
let's do it in one go.
One video.
What sequences have we got today then, Miss Cheeseman?
We're gonna kind of go with a linear sequence. Linear sequence.
Okay.
Where we're
linear.
aiming for the nth term, and we're going to be looking for the nth term. We're going to be discussing finding terms as well. You will see this mentioned a lot. Nth term, find an expression in terms of n. They like to say it in all kinds of different ways.
Ways of saying the same thing.
So
let's go.
Yeah, we're going to go with that. One. So here's one. You will recognise this sequence. You will see it.
Multiples of 4.
You think
multiples of 4. You think?
You think 4 times table.
You would.
You'd be thinking, well, 4 is 4 times 1, and 8 is 4 times 2, and 4 times 3, and so on and so on and so on. Does this sequence ever end, Mr. Coulson?
No.
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 Is that infinity again?
It's 4 times infinity. It's 4 infinity. 4 infinities. Jacob, work that one out.
So, it goes on, it goes on, it goes on, and you can find any number in this sequence. If we wanted to find the 50th term in the sequence,
I would guess it's 4 times 50.
It would just be 4 times
4
50.
Times 50, yeah.
And the 50th term would just be 200.
Okay.
This is the first term,
yep.
the second term, the
yep.
third term, the fourth term, the fifth term,
the 50th
term, and the nth term would just be 4 times
n. Okay.
And we can just write that as 4n.
Okay.
So the nth term of that sequence is just 4n. It's going up in 4s.
Okay,
multiples of 4.
That seems
easy.
In
4s. Okay.
Yeah.
That's how we decide it, because it's going up in 4s. So this one is 4n. So what do we think this one will be if we look at the comparisons?
It's going up in 4s again, isn't it?
Yeah, so we can write down 4n. We've got that in the bag.
Okay,
it's going up in 4s.
This tells me what it's going up in. It's going up in 4s.
Yeah.
But it's different. It's out by a certain amount. It's not quite the same. In fact, that's one more, one more, one more, one more, one more. So it's this one, but plus with one more.
4n plus 1.
Okay, yeah.
Okay. Nice. So if I write us a completely different sequence, and 11x1, remember, whenever I write off sequences, sometimes I write them completely wrong. So
I do the same. That's good.
It's good.
Thinking on your feet.
It's going up in
3s.
3s. Okay.
That tells me then that that bit is 3n.
Yes. Now my bit, the way I explain this,
go for it.
Is how far away it is from the first term. What would I have to do to the difference to get to the first term?
I don't understand what you mean. Explain that a little bit more.
What would I have to do to the difference to get to the first term?
So you times 1 by 3 and get 3, but then you're 3 out.
Yeah, and it's always times by 1, so that's why I always cut that bit out, and I always just say, well, how do I go to the difference to the first number?
Right, okay.
It's nice and
then
quick.
You add 3.
And you add 3. I'll do that again.
Just
thinking, I feel like I've slightly thrown Mr. Casey off then, but I'll do it again. This is what I mean about everyone does things differently, and that's why when you go from one class to another class and you get a different teacher, you're like, what is that teacher saying? So
5.
It's going up in 5.
5n. Okay, and
what do I have to do to 5 to get to 1?
You've got to take off 4.
Boom. And you can always check if it's right. With the 5, take away 4, that will give you the first number.
Okay.
4 plus 1 will give you the first number. Oh, do you want to go for it?
No, I'm just going to say that what I've been shown, and I've been shown lots of ways, because obviously I'm much older than Miss Cheese, so I've been shown lots of ways of doing it. And I remember I did it a certain way as well, but someone then told me about the 0 term.
Oh yeah, the 0
which is
term.
going back. If I go back by 5, I get to minus 4, which is the 0 term. So some people call this the 0 term because they go back by the difference. So the difference gives us this number, and then the 0 term gives us that number.
Yep.
I equally like that. What do I have to do to it to get to that? Equally good. Both work.
Nice,
so I'm happy with either of those.
Nice and smooth.
Beautiful.
So what we'd like you to have a go at is those 3.
So we're freeze.
We'll freeze away from the board.
Yeah, because we get complaints about being in front of the board.
And we're back. So let's go green. Let's switch it up.
Nice.
Okay, I am going up in
10.
tenths. So I'm going to say 10n.
10n.
What do I have to do to 10 to get to 6? Take away 4.
Take away 4.
What's the 0 term? Minus 10 is it's 4. Minus 4.
Excellent.
What? Ooh.
Getting a bit of half, are you?
She's crazy. She's going up in 0.5.
Crazy town, crazy town.
What
so
do I?
Should I put? I could put a half n.
Yeah.
Or I could put 0.5 n.
Either is beautiful.
Happy with either.
What do I have to do to 0.5 to get to 3? Add 2.5. Or what is 3? Take away 0.5. It is 2.5.
Add 2.5.
So you can do it whatever way you like. If you
I
are
hope you
a
got
fan of Mrs. Barham's box and ring method,
Ooh.
of course you can use that as well. No.
No.
We don't like it, but it's fine. It's all good.
It's all good.
Ooh.
You're going down.
Down in minus 1, so I'm saying it's minus 1n or just minus
Shall I put minus n?
Yeah.
Minus 1n?
Let's put minus 1n as well, just in case people like that. What do I have to do to minus 1?
We're happy with either of these.
Yeah. What do I have to do to minus 1 to get to 10? I have to plus 11.
11.
Or, see, this is where I'm like, this 0 term.
Oh, see, 0 term you have to minus 1.
Minus, then you just throw
we all know minus and a minus is a
minus,
plus, come on.
Minus businesses. Oh, I've now mucked it up to 11. Okay?
Yep.
That's perfect. That's actually.
Is that it?
Well, I think we could go. I think we could go one more.
Could we not do the one where they say, "Is this number in the?"
Exactly what I was thinking.
Is that what you're thinking?
So let's throw it in there as a question. So part A would be find the nth term.
Okay.
So find the nth term. Mr. Casey's going to find the nth term.
Okay, so we'll just do that. We're going up in 2s. Yeah?
Yeah, 2n.
2n. And if you do your little thing here where you've got your 2 and your 2 and your 2, what do I have to do to that to get to that? I have to add 1?
Add 1.
Add 1.
Or minus the 2 and you get 1.
Yeah.
Beautiful.
I'm liking your method.
And
B.
now it will say
Show
that, now it could choose anything, okay, so I'm going to go with 121 is in the sequence. Now, if you want a method that works every single time, you will choose this said method, okay?
Go for the said method.
So, as we said, if I put in 1, 2 times 1, and add 1, I get this number here. 2 times 2 for the second term, add 1, I get this number here.
Yep.
Is there a number that I could put in here that would give me 121? That's what we're trying to prove. Because if there is, that means it's in the sequence. So, how do I find an unknown? I find it.
Bit of algebra.
By solving.
Solve this.
Okay, so I'm going to minus 1 from both sides. I'm going to get 120 is 2n. I'm going to divide by 2, and I'm going to get n equals 60. And that means actually 121 is the 60th term.
Yeah.
Now, if I don't get a whole number, that means it's not in the sequence, because it means there isn't a term in the sequence that would give you that. It has to be a whole number.
Because it's either the first, the second, the third, the fourth. It can't be the 5th and a half.
Yeah.
Because the 5th and a half doesn't actually exist in that sequence.
Okay, so that could be something that it asks you.
Beautiful.
In this one as well, you could have said 121 is odd, therefore it is in the sequence. Or if I was to write out my sequence until I get to 121.
You could do it that way. You could do it that way.
It takes you a long time.
Yeah.
That's a bit of an Alec method. He likes to kind of write everything out.
But this word.
It's the show.
This word, we're showing it. You know,
yeah.
we are showing it with this.
We're showing it, and it will work every single time.
Yeah.
When it's a sequence where you're not sure if it's obvious, where it's a sequence when the number isn't in it, the equation will always work.
Yeah.
Okay.
Lovely.
Foundations?
We're finished foundations.
Okay. You can go on to Show My Homework today, and there is some SAM learning for you to do. You can have a look at the quadratic sequence L, which means the lower version, and that could come up on foundations. So take a look at that. So you might want to watch the first part.
Yeah. Stay tuned. Stay tuned. Here we go.
Quadratic.
Okay.
So this is one we're starting with. Okay. Now, with a quadratic sequence, you will know that it's quadratic from the first step. So when you do an nth term, you do the first step and you get the same difference every time. Here I'm going to do it and
oh
my, and
7.
oh. okay, and I don't have the same difference.
Differences are different.
Yeah.
Not good, not good.
That tells you quadratic. So you find the difference of your difference, you get a bit of normality, and it's 2.
2.
Now, this is the next step, and I say to my guys, just do it and just accept it, and don't ask me why, because I don't know. Even though I've got a maths degree, really should know, but I don't.
Can't know everything.
No. So what you do, once you get your second difference, you halve it. No matter what it is, you halve it. And that tells you what n squared numbers you have. And I have the 1 n squared numbers. And I always make that conclusion that it is that, okay?
Did you know, if you come down 3 sets of differences, it's a cubic term.
I did know that,
And
yeah.
you have to divide by 6.
Oh, like, because
Because
I don't know.
rules.
So
But we never have to do that. We never have to do that because that's not GCSE.
When I'm at this, alright, 2 divided by 2 is 1, and I'm a big fan of keeping consistency with no matter what it is, and I write that down because that actually is your first mark, and if you don't write that, this used to be 3 marks, then last set of marks it was 2 marks. So they're just not very nice to you.
So let me just recap then. So if you came down here and then you came down here and this was 5, 5, 5.
Yeah.
This would be
2.5
n squared or 2.5 n squared.
Correct.
Because it's 2, 2, 2, we divide that by 2 and we get 1 n squared.
Yeah.
Okay? Brilliant.
Okay. So you now take your sequence. So I'm going to switch up colour.
Good.
You take your sequence, and whatever you get here, it's these numbers that you're going to minus. So the 1 n squared numbers or the n squared numbers are just the square numbers, okay? But if you've got 2.5, you'd want 2.5 times the square numbers.
Can I just, so this is your first, your second, your third, your fourth, and your fifth. I just want to kind of, that's our terms, isn't it?
Yeah.
You happy with that?
Yeah.
You sure?
Yeah.
What are you laughing at?
I feel with this question, you end up with so many numbers.
Yes, you do, I like numbers.
That they're going to be like, what numbers are what? But it's fine.
1, 2, 3, 4, 5. That's obvious.
That's first, second,
third, fourth, and fifth.
So I'm going to write down
25 comes next.
All of my numbers. Thank you. These are my 1 n squared numbers, and I'm going to minus them to find the difference. The difference between my sequence and that
this
sequence.
sequence.
And in this case, it is just
2.
It's 2 more. Just like when we started with 4a, 16, blah, 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 blah.
So we're saying that if we had n squared and we added 2, we'd get your sequence.
Yeah.
So we've got n squared
plus 2.
Plus 2.
And that's my answer. Let's type that in a nice big box. That's your answer. Okay, that's a really, really simple version. Okay, because it can stack up. Because we see the word quadratic here. Okay, at the moment we've got n squared plus 2. It's just a nice little simple one. But it is going to become sometimes maybe a 3 term. So I'm going to jump on. I don't think this one is.
Okay.
I think this one's
Let's
another
see what
simple
this
one. Just to keep everyone going. So, first difference.
Find the difference.
9.
Yep.
15.
Yep. Ooh.
No.
21.
21. And then I'm guessing that one's 27.
27, yeah, it is.
And therefore my difference of my difference is
6, 6, 6.
So I go, oh, scary. So I go 6 divided by 2 and I say they are the 3 n squared numbers.
Mark?
Mark.
Mark.
Got your first mark.
Got your first mark.
All of that. Okay?
That wasn't too difficult, really.
No. Then we take our sequence.
Mm-hmm.
And I'm going to label them just for Mr. Clayton.
First, second, third, fourth, fifth.
Okay, and we're going to minus our 3 n squared numbers. Okay. Now, 3 times the n squared numbers, yeah? Not 3 times 1 squared. Not that. 3 times 1.
I've got to do 1 squared times 3.
Which is 3.
2 squared is 4 times 3. 3 squared is 9. 3 nines. 4 fours are 16. 3 16s. And 5 5s are 25. 3 25s are 75.
And I'm minusing.
So that's what we want to get. That's what 3n squared gives us.
So our difference is?
Oh, brilliant. It's just a number.
So our answer is going to be 3n squared plus 4. I love it. It is one of my favourite things.
That's good, that's good.
Right, second it up a notch, I hope, on
Okay.
this next one. Okay, do you want to go through Mr. Casey? I feel like I've been hogging the
No, you carry on
sequences.
hogging. You carry on. You love sequences. I'm just standing here watching.
I'm just loving it. Okay, so 1, 6, 5, then we've got 9, then we've got, I'm guessing 13, and then we've got 17. So, our difference is 4.
Oh,
So,
can we say, okay, so we got our 4, we're going to divide that by 2, so we're going to get 2n squared.
Beautiful.
So 2n squared gets us our first mark.
Gets us our first mark, we've got that in the back. Then we're going to
Changing
take
colour.
our sequence.
Okay. Can I write the numbers at the top?
You can write
Just
the
so
numbers
I know what
at the
I'm
top.
doing. Okay. 1, 2, 3, 4 and 5. We've got 5 numbers, that's a little bit shoddy.
And then we're going to minus our 2n squared numbers.
So we need to
it's
work
1
that
squared
out.
times 2, which is 2.
2 2s are 4, 2 4s are 8.
8. I mean, I just know them, but
18. Yeah, I'm just, not everyone knows
yeah,
them.
but
2 6 is 32.
they should know them
Okay.
because it's just the square numbers times 2. Just you know your square numbers, you should know
Find
them.
the difference.
Oh, okay. So we've got minus 1, minus 2, minus 3, minus 4, minus 5. Now here, this is what I tell my guys all the time, okay?
That's a pattern.
It is a pattern, it's not just a difference.
Yeah.
Your difference is a sequence. Now you need to find the nth term of that sequence. Now it's really important now that you hone in just on those numbers. And this is what I was saying earlier about not getting confused with the amount of different numbers.
Yeah, this is a lot. We put a lot of working out in order to get to this point.
So you just want to focus in on this, and that's what I tell my guys is just highlight that sequence, and take yourself back to what we started with. Okay, take yourself back to just finding the nth term of that sequence. Ignore everything else.
Because we've already got that in the bag.
That's
we
in
know
the bag.
the 2n squared is all of this stuff.
Now we're
this is the extra
here.
little bit.
So just as we started with, what's the difference? It's going down in minus 1. So that's minus 1. N. How do I get from minus 1 to minus 1? Well, I don't actually need to do anything, but if I want to be consistent, it would be plus 0. So my answer is 2n squared minus 1n. And I don't really need the plus 0. But you can write down. You're not going to get any negative marks for doing that. That is your answer.
And I might even take that out.
Yeah. Beautiful. That's your answer. But even if you wrote, oh, I'm an eraser.
Yeah.
Even if you wrote that,
that is your answer.
Right.
We're happy with both.
We're happy with both.
Both are correct.
If we're being consistent mathematicians, this would be perfect.
Yeah.
Okay. My last example kind of looks like something we already know. So, difference. We've got 5. Then we've got, why is my brain not working? 7. Then we've got 9. Then we've got 11. So the difference of my difference is 2. So it's 2 divided by 2, which is 1. So I've got 1n squared.
Ooh.
Okay.
Yeah.
Now I'm going to take my numbers. And I'm
4,
going to
9,
minus
16,
from
6.
them. Let's label them.
1, 2, 3, 4, and 5th.
Going to minus the 1n squared numbers, which is quite easy because that's just the square numbers.
Square numbers.
1, 4, 9, 16,
Lovely.
25.
Ooh.
Difference in my difference. 3, 5, 7, 9, 11. My difference is a sequence.
Put a little box around it like I did last time. So I'll move this up slightly. Focus just on this. This has been got already with all this work. Bit of working out. We've now got the difference that we've got to add on.
So it's 2.
Subtract.
So it's 2n. How do I go from 2 to 3? I plus 1. So my difference is a sequence. So my end answer is 1n squared plus 2n plus 1. Crazy. Okay?
Beautiful.
Now, I'm going to give you 2 to do, just 2, because I think any more would be too much.
Yep.
And then we'll run through those.
Got a new board?
Yep, new board.
New board.
19, 34, 53. And our second one for them to do is going to be 4, 11, 22, 37, and 56. So, go back to the first one, write that down.
Write that down and have a go.
Have a go at that one.
And we're back.
We're back. So I'm going to do the whole thing, and I'm going to do it all in one colour now because you do not have the luxury of 50 different colours.
Well, 47, I think.
in the exam. So we've got 7, then we've got 11, then we've got 15, and then
19.
we've got 19. Now you can use your calculator, obviously you're in a calculator paper, don't be afraid to use your calculator. 4 divided by 2 is 2. So I'm going
2n squared.
and I'm circling it and I'm saying, hey, marker.
Got a mark.
Give me a mark. I've got 1, 8, 19, 34, 53. That is my sequence. That's the first of my sequence, the second, the third, the fourth,
And the
and
fifth.
fifth. I'm going to minus 2 times
lots
the
of
square.
n squared.
So it's 2, 8, 18, 32, and 50. Now, the more you practice it, the more that will be fluid to you and you'll just know them, okay? Quadratic sequences wasn't on the syllabus when I was at school, so I have learnt those over the years.
Too young.
Right, minus 1, 0, 1, 2, and 3. Focus in.
It's another sequence.
It's going up in.
Do you want me to give you a little bit more balls there?
Yes, please.
There we go.
It's going up in ones. How do I get from 1 to minus 1? I have to minus 2. So my end answer is.
Well, we've got the 2n squared bit that we got at the beginning, and then we're going to have to
That's the
add
difference.
an n. I'm going to write 1n, just so we can see where it comes from, and then minus 2 to finish it off.
And that's perfect.
Beautiful.
Right, the second one.
Second one, boom.
Right, write it down. Have a go. And
we're
now
back.
we're going to
Here
go,
we go. We're
through,
gonna go
it.
through it.
So I'm going to go red this time.
Red.
So I've got 7, 11,
Yep.
15,
15.
and 21? No.
Yes. No,
19.
19 again. It's the same as last time.
I know.
Yeah.
Oh, is it?
Yeah. 19. There you go.
19. Okay, difference for difference is 4.
4. So we're going to have
4 divided by 2.
4 divided by 2 gives us 2. So 2n
squared.
That's our mark.
4, 11, 22, 37, 56. 2, 8, 18, 32, and 50. Find your difference. 2, 3, 4, 5, 6. Focus in.
So all of this stuff gives us this. This stuff gives us this, which is what we're going to add on
And now
or
we're going to
subtract.
focus in on
it.
just these
Bit more
numbers.
room.
Yes, please.
There you are.
It's going up in ones. What do I have to do to 1 to get to 2? I have to plus 1.
Okay, so this time, this bit which we worked out at the beginning, the 2n squared, and then this little bit to try to tweak it, plus 1n plus another 1.
And you're done.
Right, that's beautiful.
Okay, so all of the work is on Show My Homework and Sam Learning. Have a go, guys.
Shout out to Michael Bublé. The music at the beginning and the end, one of my favourite bits of music of all time. Thanks to Michael Bublé. It's on his Christmas album. We're not allowed to advertise, but just buy it. It's great.
It's great. Thanks.
We'll see
Michael.
you. Bye.